So these next few sections I'm kind of merging together with these handouts. So we're going to do mostly work from these handouts. You will have some bell work and all from your book. But mostly from these handouts, we're going to be doing all the different ways to prove that triangles are congruent. Okay? And so what you're going to have is you're going to be given a figure. They're going to give you certain information, and you're going to have to use that information that didn't just prove that the two triangles themselves are congruent. And then sometimes you'll have to prove after that that a specific piece of the triangle is congruent to another piece of the triangle. The first thing I want to talk about is reasons that you would have congruent sides and congruent angles. So this is at the bottom of the one-page handout there. Reasons for congruent sides. It's given. Okay? That's the most obvious reason. If they give you the fact that the sides are congruent, then you can automatically know that they are because they told you. There are two ways they can give you that information. The first way they can give it to you is actually saying this side is congruent to that side. All right? The other way they can do it is by marking it on the diagram. So if you see the little dash marks that indicate the sides are congruent, you can also say that it is given. All right? So if they tell you either with verbiage or with notation that sides are congruent, you can use it. The second thing, definition of midpoint. Sometimes in the given, they will tell you you have a midpoint. The midpoint automatically tells you that two pieces are congruent to each other. And very often these two pieces are on the two different triangles that you're trying to prove. And so if they say this is a midpoint, what they're trying to get you to use is the definition of midpoint to say that two pieces are congruent. And then the reflexive property. This seems that you would not use it very often, but you actually do with this type of proof. Sometimes the two triangles share a side. And so you will have to actually state, hey, side AB is congruent to side AB, which seems like, of course it is. But because AB is part of triangle 1 and triangle 2, you actually have to state that it is congruent to itself because it is two pieces considered a piece of that triangle and a piece of this triangle. And so the reflexive property, any side is congruent to itself. All right, look at the angles. Why are angles congruent? Again, it's given. Once again, they can tell you it is congruent or they can use it with notation. The little arcs tell you when when angles are congruent. So a single arc to a single arc means that those angles are congruent. Vertical angles, we know by definition of vertical angles that they are congruent. So if in the picture you have vertical angles, then you would tell me that those are congruent by definition or by the vertical angle theorem. By the vertical angle theorem, they are congruent. Alternate interior corresponding angles. In order to use those, you must have parallel lines. So here's the deal. If they have a proof and in the given they tell you you have parallel lines, more likely than not, you're going to use those relationships. You're going to use alternate interior angles. You're going to use corresponding angles. So if they have told you you have parallel lines, they are telling you that for a reason. They are telling you that so that you can say, hey, these are alternate interior angles. Therefore, these are congruent. All right? And then angle bisector. Once again, if in the given they tell you you have a bisector, what they're trying to get you to know is that, hey, you have two angles that are congruent because a bisector cuts the angle in half. All right? And so you're looking for these key things in your given to see that you have congruent parts. The last thing that you have is congruent parts or corresponding parts of congruent triangles are congruent. We covered this yesterday, but this is something you're going to use when you start doing your proofs. If you have congruent, very often you will be trying to prove that two pieces are congruent. All right? So they won't say, hey, prove the triangles are congruent. They'll say, hey, prove that these two pieces are congruent. And what you'll have to do is you'll have to go through the process of proving the triangles are congruent. And then your last step is going to be this guy. Hey, if the two triangles are congruent, then I know these two pieces are congruent because corresponding parts of congruent triangles are congruent. And so in your reason, you can actually just list the acronym, the CPCTC, and you don't have to write the whole thing out. But you have to prove first that the triangles are congruent to then be able to prove that these corresponding parts are congruent. And vice versa. If you're trying to prove the triangle is congruent, you have to have the correct parts. All right? This is the first one that we're doing. If you can prove that all three sides of one triangle are congruent to all three sides of the other triangle, then you can assume the two triangles are also congruent. So here's how it reads. If all corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, you can prove it with fewer pieces. The first way is side, side, side. And so you'll notice that we have AB, side AB, and it has that congruence mark corresponding to side DE. You can see that side BC has the congruence marks that correspond to EF, and you can see that AB has the congruence side to DF. And so if you look here, AB is congruent to DE, BC is congruent to EF, AC is congruent to DF. If you know that and can prove those three sides, then you can say, by the theorem, side, side, side theorem, which is what this guy is. So by this theorem, I know that the two triangles themselves are congruent. And so that's the first way we're going to prove triangles are congruent. We are going to go through this process and try to prove that their sides are congruent. So at the top of your single sheet handout, you'll also see side, side, side. All right, side, side, side. You see side, side, side at the top. As you do the proof, as you prove that one side is congruent to another side, I would recommend that on your worksheet you mark it. So if you can prove that this side is congruent to that side, mark it on your figure so that you can visually see, okay, I've got one side, they are congruent. And then as you prove the next side congruent, you want to mark that as well. All right, I have two sides congruent. And then again, as you have the third side, then you can finally say, I have the triangles congruent. And so when you're doing side, 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 your whole goal is to prove each side congruent to the corresponding side of the next triangle. And so I recommend that you use color, and I recommend that you use your notation to pay attention to how you're moving along in your proof with these. So let's look at the first proof. It says, given that PQ is congruent to ST and QR is congruent to TR, R is the midpoint of PS. And so I'm gonna first, I don't think y'all's actually, all right, they've given us QR congruent to TR. And so these first two things right here, we know because they told us. They told us this right here. They told us this one right here. So what's the reason we can write that down? Yeah, so these are both going to be given. Those are both given. And then on your figure, you want to actually mark it. So if PQ is congruent to ST, you want to mark it. If QR is congruent to TR, you want to mark it. And so not only do you want to write it down in your proof, you want to mark it on your figure so that you can visually see what's congruent. All right? R is the midpoint of PS. R is the midpoint of PS. Well, why do we know that? It's also given. So at this point, you have exhausted your givens. All right? Now here's the deal. Anytime they give you a blatant definition staring you in the face, you're likely going to use the definition. Midpoint. I mean, they said midpoint. It was no accident. You're going to use the word midpoint. And so you're going to say, well, if R is the midpoint then of PS, what does that tell me? Well, it tells me that I have congruent pieces. It tells me that I have PR congruent to RS. I have PR congruent to RS or SR. I know that by what? The very definition of part of my given. So definition of midpoint tells me that. And so now that I have that, I'm also going to mark that on my figure here. And so if you look at your figure, you have 3 congruent sides. You are done with this proof. All you have to do is tell me. I now can say that PQR is congruent to STR, and I know that, and I can simply write side, side, side. So you can write, well, I have all three sides congruent, therefore I know they're congruent. Now here's what I will forewarn you about. First of all, you're proving that it is congruent, so you must have it exactly the way they have it here, all right? You must have your triangle mark, all right? So you have to have your notation. Triangle PQR is congruent to triangle STR. You must have that, all right? It cannot say equal. It has to say congruent. It must look exactly like what you're trying to prove. If it is flip-flopped, you're going to have to use your symmetric property of congruence, okay? So if for some reason you wrote it flip-flopped, then it's not going to be right. You actually have to have it exactly the way they want it proven. All right, so go ahead and try number 2 on your own. Number 2 on your own. So this first one, JL is congruent to NM. Why do I know that? That is given. Also, K is the midpoint. Why do I know that? All right, and what about JK congruent to NK? Definition of midpoint. LK is congruent to MK. Also definition of midpoint. And then my last one is side, side, side. The second way that we can prove that triangles are congruent is side, angle, side. Side, angle, side. If two sides and the included angle of one triangle is congruent to two sides and the included angle of another triangle, then the two triangles are congruent. I want to point out right here, included means the angle between the sides. So it's very, very important that if you have AB congruent to DE and BC congruent to EF, the angle that is made up from those two sides is the one that must be congruent. It has to be the one in between them. You cannot have another angle, all right? If you have either angle A congruent to D or C congruent to F, it won't work. It must be in between because you don't have a congruent triangle at that point. It actually could continue going and it's not going to work. It's not going to work. All right? It could actually be a different angle, right? You could create a different triangle with it. So it must be the one in between. It must be the one in between, okay? Because it leads to the theorem of the angle opposite proves that the other side is actually congruent. You could go one more step. And so you must have the included angle, not a third one, or not one of the other two, rather. It has to be the one in between those two sides to be able to use side, angle, side. All right? And so if you have those two sides congruent and the included angle, then you can then say it is congruent based on side, angle, side. So let's look at the next proof. This is actually your little one-page reference. So as you do these proofs, once you have a side congruent to another side, then you look and see what else you have, all right? So let's say you get a second side congruent to a second side. At this point, you have two potential options here. It is possible that in your proof, you're going to be able to prove the third side. Well, then you're going to do side, side, side. Or it's possible you could prove the included angle. Then you know you have side, angle, side. So as we start building these, you're going to have to look and see what you have, and then all the options for the potential proof of the two triangles. In this case, we've only learned two, side, 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 and side, angle, side. So if you have two sides, you have to look and see which of the things you can prove. Can I prove another side or can I prove an angle? All right, and then you're going to try to see which one you can use. So let's look at this proof number 4 at the bottom of the second page. Given JM is congruent to LN and angle JMN is congruent to angle LNM. All right. And so I will say on yours, you do not have this marking here. So the first thing we're going to say is, what have they given us? JM congruent to LN. So we know that one by given. They've also given us an angle. Angle JMN congruent to angle LMN. If it is not currently marked, you want to mark these angles and these sides congruent. So then this is a really easy proof here, because if you have these two given pieces, then you have this side that they share. And so this is the example that I used before. You have this shared side, MN. This is a shared side. And you have a side and an angle, and then the shared side, a side and an angle, and a shared side. So anytime you have something like this, you actually have to state that the side MN is congruent to NM. It's congruent to itself, which seems like you wouldn't have to, but you're telling me that because it's actually a piece of both of the triangles. So why is anything congruent to itself? Reflexive, right? And now you have side, angle, side, side, angle, side right here. And so you can go ahead and tell me that the two triangles are congruent. Make sure you list it in the order that they listed it in, and you can tell me that's true because of side, angle, side. Questions on that one? AB is congruent to CD. Why do we know that? Given. BD bisects angle ABC. Why do we know that? Angle ABD is congruent to CBD. Why do we know that? Definition of an angle bisector. Definition of an angle bisector. BD is congruent to BD. Why do we know that? Reflexive. And so now we know by side, angle, side that those two are congruent. So you should first list your givens here. I have AC congruent to AD. Mark it. AC is congruent to AD. CB also given congruent to BD. Mark it. The easiest thing to do is prove that the side is congruent to itself by the reflexive property. Once you have all three sides, you have your proof. You have your proof. Mark the information that they give you. And you could have actually done, if you wanted to, you could do the statement of the midpoint, and then you could go ahead and tell me the congruence in that order so that you know you did both of those. And then you can move to the vertical angles. You don't have to do it in the same order. Proofs can be done in a different order as long as it's a logical progression of information. All right, question on that one, side, angle, side. That they did this little arrow marking, okay? This little arrow marking indicates these are the parallel lines. That little arrow means parallel, all right? So when you mark parallel lines, you may want to use that notation so that in your brain you can say, hey, I have parallel lines and a transversal. That's really what you have here. You have parallel lines here, right? And you have a transversal here, okay? Which means that these guys right here are alternate interior angles, okay? So in that proof, when they told you that those two angles are congruent, the reason you know they're congruent is because alternate interior angles are congruent, okay? So number 3 is the fact that they're alternate interior angles. Then they told me HJ is congruent to HJ, or JH, doesn't matter the order there. Why do I know that a line segment is congruent to itself? Reflexive property, and then I have my side, angle, side. All right, so anytime you see the word parallel, you are going to be looking for those special angles that are created with parallel lines. Let's look at number 1. Number 1 is right there. You have a side congruent to a side. You have another side congruent to a side. And you have this angle in between them congruent to the other angle. So they have actually given you all the information you need here to be able to say, yes, these are congruent by side, angle, side. And then they want you to write a congruent statement. So if they're congruent, write a congruent statement. So they want you to say, well, then I can say that triangle YQT is congruent. Now, how do I write the next one? Well, Y is congruent to K, right? So K needs to come first, all right? And then I'll tell you how I do this. If I go from Y to Q, I have one congruent line mark here. So then I'm going to go from K to C for that one congruent line there. So I know the next one should be C, which leaves my third one, P. you have to write those congruent statements in the right order, okay? And so you have to then look at it based on what is congruent to what. We know the angle that's congruent. Y is congruent to K. That's easy. But then you look for those congruent marks either by angles or by sides to determine what order to put it in correctly. Now, sometimes it'll be like this, and they'll just hand you all the information and say, hey, those, you have everything you need to say side, angle, side. But then look at number 2. Number 2 only gives you 2 sides, and it doesn't give you any angles. So very often I'll have students say, no, these aren't congruent. I can't say they're congruent. But I actually can. Why can I say these are congruent?
Because AC is congruent to itself.
Right, I could prove it with just one thing. I don't need a given to prove this. I don't need any other information to prove this, because I can look and say this guy is the same side. So actually, yes, these are also congruent by side, side, side. So if in the picture they've given you vertical angles, or if in the picture they've given you a shared side or a shared angle, then you can use that information to say they are congruent. They won't always be congruent. If you cannot say they're congruent, then you might not be able to say they're congruent, all right? So you might have to say, no, these are not congruent. I don't have enough information to say that. But in this case, I can. I can say that triangle ADC is congruent to triangle CBA. Let's look at number 3. So for number 3, I have JM congruent to LK. I also have an angle M congruent to angle K. Now notice I have 2 triangles here and they overlap. Because they overlap, they actually share this side. So actually I have another side congruent. I have side MK congruent to side KM. And so I have 2 sides, this side and that side, and I have the angle that is shared. So I can say these are congruent. These are congruent by side, angle, side. Side, angle, side. And then, if I want to say the congruent statement, triangle JMK is congruent to triangle LKM. Let's look at number 4. So for number 4, I have SU congruent to TU, and I have SV congruent to TW. I do have an angle. What's the problem with this one? Where is that angle? It's not in between them. So these 2 angles, based on the information that I have, are not congruent. So you would say not congruent, or at least you can't prove it. So you would list this as not congruent based on the information that you have. Based on the information that you have, you cannot say that these are congruent.